This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now, let's get into it. The central field decision is simple. I do not let heating and cooling equipment get selected from a square foot shortcut and then ask for paperwork after the unit is already sitting on the job. The load comes first. The equipment selection follows the load. The documents must support both. That does not mean a General B contractor becomes the mechanical designer. It means the General B recognizes the boundary, hires, or coordinates the properly licensed people, and checks that the required design and compliance work exists before procurement, installation, and inspection lock the project into a bad decision. A bigger unit is not automatically a safer choice. A bigger unit can cool the air so quickly that the thermostat shuts it off before the system has operated long enough to manage moisture well. The result can be a house that reaches the temperature setting but still feels damp and clammy. That is the central connection I want you to remember. Load calculation is not paperwork for paperwork's sake. It is the bridge between the building that was actually designed and the equipment that is actually installed. California Business and Professions Code, Section 7057, defines the general building classification around projects that involve multiple, unrelated building trades or crafts. The word general does not erase specialty boundaries. For a multi-trade project such as a new home and addition or a substantial remodel, a General B contractor can coordinate the heating, ventilation, and air conditioning scope as one part of the larger project. The contractor still has to use properly licensed specialty people where the law requires them, and still has to coordinate permits, plans, inspections, and energy documentation. A standalone heating and cooling project is different. Based on the source material for this lesson, a General B contractor may take that single trade prime contract only when the contractor also holds the appropriate specialty classification, or when the specialty work is subcontracted to an appropriately licensed specialty contractor. Without one of those paths, the General B classification alone is not a universal heating and cooling license. The research report contains one conflicting hypothetical about that exception. I am following the report's California First Rule and Clean Room Teaching boundary because both state the same rule. Hold the specialty classification, or subcontract, the specialty work to an appropriately licensed specialty contractor. That boundary matters before the proposal is signed, not after the crew arrives. Imagine a homeowner asks for nothing but replacement of a furnace and condenser. I would first identify whether the contracting structure fits the General B classification. If the General B also holds the C20 classification, that is one lawful path described in the research. If the General B will subcontract the specialty scope to a properly licensed C20 contractor, that is the other path described in the research. If neither condition exists, I do not treat the word general as permission to self-perform the specialty project. Looking at this boundary as a table helps separate project coordination from specialty performance. The General B can control the schedule, sequencing, documentation, and integration of trades on a qualifying project. The General B does not gain automatic authority to perform specialized heating and cooling work merely by being the prime contractor. This is a testable concept based on the Contractor State License Board Study Guide because the heating, ventilation, and air conditioning topic appears within the core trades area, while scope of work, code compliance, coordination, and error identification also appear within planning and estimating. The practical skill is recognizing which decision belongs to the General B and which decision must come from the specialty contractor or designer. The three manual names are easy to blend together, so I separate them by the question each one answers. Manual J answers, what is the building load? It is the heating and cooling load calculation. It accounts for the thermal characteristics of the specific building, including factors such as orientation, insulation, window performance, and climate. I'm not teaching the mathematical execution because that belongs outside the General B supervision boundary established for this lesson. I am teaching what the document is for and what the General B should verify. Manual S answers which equipment matches that load. Under the source-backed California requirements for this episode, equipment sizing and selection must be based on Manual S 2023. Manual J gives the demand. Manual S connects that demand to the actual equipment selection. Manual D answers, how will the air be distributed? It is the duct design method. A correct load and a correctly selected unit do not automatically produce a working system if the duct design cannot support the required distribution. The General B does not need to calculate duct friction in this lesson, but should recognize that duct design is a separate coordination step rather than an afterthought. I remember the sequence as load, machine, path. Manual J is the load. Manual S is the machine selected for that load. Manual D is the air path through the duct system. That memory aid is simple, but it prevents a common mistake, using Manual J as a catch-all label for the entire mechanical design process. Suppose a mechanical subcontractor hands over a Manual J report and then orders equipment that does not follow the load. The presence of the first document does not cure the second decision. The calculation and the equipment selection have to connect. That is why the General B review is not limited to asking, do I have a Manual J? The better supervision question is, does the specified equipment trace back to the calculated load through the required selection method? The same logic applies to duct coordination. If framing changes a chase, if a beam blocks a planned route, or if another trade occupies the space reserved for a trunk line, the General B should not allow the field crew to improvise a major distribution change without the proper mechanical review. The shared construction principle is sequencing. A late change in one trade can break the assumptions used by another trade. California standardizes important design inputs, so the load calculation is not manipulated by choosing convenient temperatures. For sizing calculations covered by the source material, the indoor heating design temperature is 68 degrees Fahrenheit. The indoor cooling design temperature is 75 degrees Fahrenheit. Those are calculation inputs. They are not a promise that every occupant must set the thermostat to those temperatures. I treat them as standardized design baselines used for sizing. Outdoor design temperatures also cannot be picked casually. The source material directs them to Reference Joint Appendix JA2 or the American Society of Heating, Refrigerating, and Air Conditioning Engineers Handbook. The project location matters because California climate conditions vary. The approved source supplies the outdoor design value rather than a salesperson, owner, or contractor choosing a dramatic number to justify larger equipment. For additions, the source material states that block loads are permitted for calculating system sizes. A block load is the combined total load for all rooms served by the central equipment. That permission is specific enough that I do not expand it into a universal shortcut for every project. I use it as the research gives it, as an allowed approach for additions. Here's the field supervision point. The General B does not need to recreate the load calculation. The General B should be able to ask whether the correct indoor design temperatures were used, whether the outdoor value came from an approved climate source, whether the project qualifies for a block load approach, and whether the equipment selection follows the completed load. A contractor who changes a load input merely to make a preferred unit fit is not solving a design problem. That contractor is changing the premise. The better response is to send the mismatch back to the qualified designer or C20 contractor before equipment is purchased. Oversizing is the most useful defect recognition example in this lesson because the complaint can sound backward. The house may cool quickly, yet the customer is unhappy. An air conditioner handles sensible load and latent load. Sensible cooling lowers the air temperature. Latent performance addresses moisture. When an oversized system has more cooling capacity than the building needs, it can pull the temperature down rapidly and satisfy the thermostat after a short run. The short run is the problem. The system may stop before it has operated long enough to remove moisture effectively. The space can feel cool but damp. Depending on surrounding conditions, repeated short cycling can also contribute to condensation, concerns, comfort complaints, and unnecessary mechanical wear from frequent starts and stops. The sequence is worth seeing plainly. Oversized equipment creates a rapid temperature drop, The thermostat is satisfied quickly. The unit shuts down. Moisture removal is limited. The occupant reports a cold, clammy house. I am not saying every damp house proves oversizing. Duct problems, controls, installation defects, and other conditions can produce complaints. I am saying that rapid cycling combined with cool but clammy conditions is a defect clue that justifies reviewing the load calculation, equipment selection, and installation documents. Consider a hypothetical custom home. The owner says the system runs for only a few minutes at a time and the rooms feel heavy, even though the thermostat reaches its setting. I would not start by changing the thermostat to hide the complaint. I would ask for the manual J load, the manual S selection, the equipment model information, and the installation certificate. The goal is to compare the design basis with what was installed. The opposite mistake, severe undersizing, can leave equipment running without satisfying the load under design conditions. I mention that only as a contrast. The General B objective is not to choose bigger or smaller by instinct. It is to make the documented calculation and selection process control the decision. The compliance documents turn the design process into an inspection-ready record. The CF1R is the certificate of compliance. In the source material, it belongs to the design and permit phase. It identifies the energy features, calculation methods, and performance specifications for the project. The enforcement agency requires the building design plans and energy specifications to be submitted with the permit application. The CF1R must be signed by a responsible person who is eligible under the Business and Professions Code. The CF2R is the certificate of installation. It belongs to the construction phase. The installing contractor or technician certifies that the installed work matches the applicable design and installation requirements. I remember the pair as promise, then proof of installation. The CF1R records the compliance design that is promised before construction. The CF2R records what the installer certifies was installed. That phrase is only a memory aid. The actual documents and signatures carry the legal meaning. The General B role is coordination. I do not assume that the General B personally authors the energy calculation or signs as the responsible person unless that individual is actually qualified and eligible to do so. I do expect the General B to know who is preparing the document, who is responsible for signing it, whether it is complete for the permit phase, and whether the installation certificate will be produced for inspection and closeout. This is where many schedule problems begin. Equipment is ordered before the final selection is documented. A model changes because of availability. The substitution is installed. Then the paperwork is treated as a clerical cleanup task. That reverses the process. The documents should control and record the decision, not be rewritten after the fact to excuse an undocumented substitution. Imagine a project where the specified heat pump becomes unavailable. The supplier offers a different model with a similar nominal size. Similar is not enough by itself. I would send the proposed substitution back through the qualified mechanical selection and compliance process. The relevant question is whether the alternate equipment still matches the calculated load and the required selection method, and whether the compliance documents are updated before installation. The heat pump rules in the source material provide good examples of details that the General B should recognize and coordinate without pretending to be the commissioning technician. When a heat pump has an installer adjustable defrost delay timer, the delay must be set to at least 90 minutes. Supplementary heating must be locked out when the outdoor temperature is above 35 degrees Fahrenheit, except during defrost or emergency operation. The source material also limits electric resistance supplementary heat capacity. The maximum is the nominal cooling capacity multiplied by 2.7 kilowatts per ton, rounded up to the closest kilowatt. For example, consider a 4-ton heat pump. 4 multiplied by 2.7 equals 10.8 kilowatts. Rounded up to the closest kilowatt, the limit is 11 kilowatts. That is a simple coordination calculation, not a substitute for the full mechanical design. These requirements show why installation documentation matters. The model selection can be correct, but the controls can still be configured incorrectly. A General B, who understands the boundary, asks the C20 contractor for the required settings, tests, and installation certification, rather than reaching into the controls and guessing. The source material also states that variable or multi-speed systems must be able to modulate compressor speed in response to loads, even when a third-party thermostat is used. The practical supervision issue is compatibility. A thermostat substitution should not disable a required operating capability. I would treat a control change as a mechanical coordination item, not as a cosmetic owner upgrade. I want to tie the pieces together with 3 hypothetical field decisions. First, suppose a General B is building an addition involving foundation, framing, electrical, plumbing, and heating and cooling work. The mechanical contractor proposes a block load calculation for the added space. The source material allows block loads for additions. The General B can coordinate that approach, confirm that it appears in the compliance documentation, and make sure the equipment selection follows it. Second, suppose equipment arrives before anyone can produce the load calculation or the manual S selection. The schedule is tight and the crew wants to set the unit anyway. I would place the installation on hold. The immediate inconvenience is smaller than the rework risk created by installing equipment that may not match the documented load. Third, suppose a client asks a General B for a standalone heat pump replacement. I would resolve the license boundary before accepting the contract. Does the General B hold the C20 classification? If not, will the entire specialty scope be subcontracted to an appropriately licensed C20 contractor as described in the research? If neither path applies, the General B classification alone is not the answer. Notice that none of these decisions require the General B to calculate heat gain through a window or friction loss through a duct. The skill is recognizing when the project needs qualified design, when the contracting structure needs specialty licensing, when a document must exist, and when a field symptom justifies escalation. That is the air traffic controller idea. I am not asking the General B to fly every aircraft. I am asking the General B to keep the project airspace organized. The flight plan has to exist before takeoff. The equipment and installation have to follow that plan. The records have to be ready when the enforcement agency asks for them. My practical supervision checklist is short. Before contract execution, I identify whether the project is genuinely multi-trade or whether the heating and cooling work is a standalone specialty project. I confirm the appropriate license path. Before equipment is ordered, I confirm that the load calculation exists, that the equipment selection follows the required method, and that the specified model matches the documented design. Before rough coordination is locked in, I confirm that the duct design and required spaces have been coordinated with framing, electrical, plumbing, access, and service clearances. Before permit and inspection milestones, I confirm that the CF1R and CF2R responsibilities are assigned, signed by the proper people, and available at the required stage. Before closeout, I treat substitutions, control changes, comfort complaints, and rapid cycling as reasons to compare the installed system against the design record, rather than as reasons to improvise. The memory line is load, machine, path, papers. Manual J establishes the load. Manual S selects the machine. Manual D addresses the air path. The CF1R and CF2R carry the compliance record from design into installation. Around all of it sits the General B boundary. Coordinate the work, verify the chain, and do not cross into specialty, design, or performance that the license and qualifications do not support. I made an audio practice quiz specifically for this episode's material. It is audio-based, with each question read aloud and each answer selected by tapping, because I know many people are studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the next study session to feel as practical as the work you already know how to do.